Hello everyone, welcome back to my channel Tales of Chemistry. Today we are continuing with sulphuric acid, standard 10 chemistry lesson, sulphuric acid. In the previous episode we have completed the contact process, which is industrial preparation of sulphuric acid. And also we have completed the properties of dilute sulphuric acid. That is, dilute sulphuric acid is a typical dibasic acid. Today, we are going to discuss the properties of concentrated sulphuric acid. Mainly, three properties we need to discuss here. One among that is concentrated sulphuric acid is a non-volatile acid. First of all, let us know the meaning of the word non-volatile acid. It means sulphuric acid has a very high boiling point. It boils at around 338 degrees Celsius of temperature. So till this particular temperature, sulphuric acid will not boil or it will not form its vapors before 338 degrees Celsius. This is useful in the lab method of preparation of HCl and HNO3. Now, if you have already studied these chapters, you may remember that hydrogen chloride is prepared from solid sodium chloride on heating it with concentrated sulphuric acid at a temperature which is slightly below 200 degrees Celsius. Now, what is the advantage of this? What is the advantage of using concentrated sulphuric acid here? See, you are heating the reactants to around 200 degrees Celsius of temperature. If sulphuric acid has a boiling point which is below 200 degrees Celsius, you may end up collecting sulphuric acid vapors also along with HCl vapors. Now, since sulphuric acid is a non-volatile acid, its vapors will not be formed. H2SO4 vapors will not interfere in the reaction. What you collect will be more or less pure HCl itself. More or less pure. What I mean by that is you may have moisture and all, which you have to remove. Now, the equation goes like this. NaHSO4, along with that we will get HCl gas. NaHSO4, sodium bisulfate, sodium hydrogen sulfate, which is an acid salt. Similarly, one more equation which helps us in the preparation of HCl is, instead of NaCl, you can use solid KCl, potassium chloride can also be used, treated with sulphuric acid concentrated at the same temperature, which is around 200 degrees Celsius. You will get potassium bisulfate and HCl. Okay, the first equation is the most important one. Second equation is an alternate way of preparing HCl. If not NaCl, you can use KCl also, but we still prefer NaCl because it is cheap and easily available. Now, nitric acid is also prepared by a similar method. Here, instead of NaCl, use NaNO3, sodium nitrate. Sodium nitrate can be taken, treated with sulphuric acid, concentrated, same temperature, slightly below 200 degrees Celsius, you will be getting NaHSO4, sodium bisulfate, along with that HNO3, nitric acid. Here also we are getting nitric acid vapor, which we are condensing. We are collecting in a water-cooled receiver to condense HNO3. So ultimately we collect it as liquid HNO3. Instead of NaNO3, you can also use KNO3, which is potassium nitrate. Sodium nitrate or potassium nitrate can be treated with concentrated sulfuric acid at around 200 degrees Celsius. The products are KHSO4 or NaHSO4 as the case may be, plus HNO3, nitric acid. Now, all the four equations, you have noticed that the reaction temperature is around 200 degrees Celsius. But sulfuric acid, because its boiling point is 338 degree, will not interfere in the reaction. I mean, the vapors will not come out along with the other products. So these are the four equations as per our syllabus that we need to study to prove that concentrated sulfuric acid is a non-volatile acid. Now, another very important property of sulfuric acid is it is a dehydrating agent. Very frequently, every year questions are asked from this topic also. Concentrated sulfuric acid is a dehydrating agent. Previously, in HCl chapter, we have studied that concentrated sulfuric acid is a drying agent. Even in, 9th standard, you have studied concentrated sulfuric acid is a drying agent. But here, our focus is on dehydration. Now, what is the difference between drying and dehydration? In drying, you are just removing the physically combined or superficially present, water or water vapor. Whereas in dehydration, even if directly water is not present as H2O, but elements of water are there. Hydrogen is present, oxygen is present, and you can remove them in the ratio 2:1. That is what dehydration, here. Even if water is not present directly as H2O, sulfuric acid can still remove water, provided hydrogen and oxygen are present in the given sample in the ratio 2:1. So let me explain what I just said. One of the examples as per syllabus that we need to study is sugar. Sugar has the formula C12H22O11. Here, it is compulsory to write concentrated sulfuric acid and write it above or below the arrow. Do not write it as sugar plus sulfuric acid. Now, function of sulfuric acid is to absorb water, to remove water, but actually no water molecule is directly present in sugar. But on analysis, you can understand that the H22O11 can be written as H2O11 times. Look at this. H2 into 11, 22. O, 1 into 11, 22. Now, though directly water molecules are not present in sugar, but the elements of water, hydrogen and oxygen, are present in the ratio 2:1, sulfuric acid can remove that molecule of water. So totally 11 molecules of water are removed by concentrated sulfuric acid. Along with that, you are getting 12 atoms of carbon. Do not write C12. Do not write C12. That's wrong. 12 atoms of carbon, which is called sugar charcoal. So the product here is sugar charcoal. So we can ask a question to you here. Write balanced equation for the conversion of sugar to sugar charcoal. Write balanced equation for the conversion of sugar to sugar charcoal. The above equation has to be written. Do not write plus concentrated sulfuric acid. Leave sulfuric acid on the arrow because the purpose of sulfuric acid is to just absorb water, and eventually slightly the sulfuric acid will get diluted. This 11 molecules of water should dissolve in sulfuric acid. Okay, another possible question here is, instead of the balanced equation, they can ask you to write your observation. What do you get to see when concentrated sulfuric acid is added to sugar, or sugar crystals? So this sugar charcoal is what you get to see, but there is a particular way to present your answer. That is when sugar comes in contact with or is treated with, when sugar is treated with concentrated sulfuric acid, okay, steam is evolved. Actually, it's not a key point. Steam is evolved. Now you can skip writing this. That steam part, you can skip writing. Okay, what is more important is okay, black, spongy mass. This is the key point. Black, spongy mass of carbon is formed. Black spongy mass of carbon is formed here. So when sugar is treated with concentrated sulfuric acid, black spongy mass of carbon is obtained. That much is enough. I have just mentioned here steam because you can see the evolution of 11 molecules of water. Okay, so either the equation directly, what happens when sugar comes in contact with sulfuric acid, or the observation, or right equation for the conversion of sugar to sugar charcoal. Moving on, under this dehydration, we have one more example to study, which is blue vitriol. Blue vitriol is copper sulfate pentahydrate. Now, this is much easier to understand because 5 molecules of water are directly present, or you can see that in the formula that 5 molecules of water are in a loose chemical combination with the copper sulfate. So, when we write the equation, Cu CuSO4.5H2O, which is called blue vitriol, or it is called, its chemical name is copper sulfate pentahydrate. Copper sulfate pentahydrate. This is treated with concentrated sulphuric acid. So as told earlier, do not write plus concentrated sulphuric acid. Leave concentrated sulphuric acid on the arrow and your result, your products are CuSO4 plus 5H2O. So this is why I said it's very easy to understand this equation. You just need to, separate them. Copper sulfate is written separately. 5 molecules of water is written separately. Why is it so? Because concentrated sulfuric acid is a dehydrating agent and it removes those 5 molecules of water from blue vitriol and converts blue vitriol to anhydrous. Converts blue vitriol to anhydrous copper sulfate. Anhydrous copper sulfate, which is white in color. Now, by treating concentrated sulfuric acid with blue vitriol, the color changes from blue to white. The color changes from blue to white. Observation is possible. Okay, so I've already mentioned the observation. Blue vitriol, when comes in contact with concentrated sulfuric acid, changes its color to white. Blue color changes to white. Also, one more observation is there. This blue color is in the form of crystal. Copper sulfate is in the form of crystals, and here you will get powder. Copper sulfate, white anhydrous copper sulfate is powdery. So crystals are getting converted to powder also. Now, the last property of concentrated sulfuric acid which we need to study is it is an oxidizing agent. In fact, sulfuric acid is a very strong oxidizing agent. What will be the reason to call concentrated sulfuric acid an oxidizing agent? The reason is when you heat sulfuric acid, or in other words, when you make it undergo thermal decomposition, when sulfuric acid concentrated undergoes thermal decomposition, the products are H2O, SO2, sulfur dioxide, and nascent oxygen. Since thermal decomposition of sulfuric acid releases nascent oxygen, sulfuric acid concentrated is an oxidizing agent. Now, as per our syllabus, we need to study the action of concentrated sulfuric acid on carbon as well as on sulfur under nonmetals. Action of concentrated sulfuric acid on carbon. So carbon is a nonmetal. It is a gray color nonmetal. Gray, or you can even write black. Now, when carbon combines with concentrated sulfuric acid, look at this equation. Sulfuric acid must release nascent oxygen. Those nascent oxygens are combining with carbon to give you CO2. Means you need 2 atoms of oxygen. That in turn tells us that we must take 2 molecules of concentrated sulfuric acid. We must take 2 molecules of concentrated sulfuric acid. So this CO2 is one product. The other products are water and sulfur dioxide. So 2H2O and 2SO2. Observation chances are very less, but let us still be prepared. Gray color carbon, you can write gray color non-metal carbon, when treated with concentrated sulfuric acid, gives colorless gas that turns lime water milky. Now look at this. Carbon dioxide has no smell. It is odorless. Sulfur dioxide has a, pungent, choking odor. But we are very careful here. We are not writing anything about the odor. One has some odor, the other one is odorless. Both are gases. We won't be able to, separate carbon dioxide from sulfur dioxide. So we are writing it collectively. Carbon dioxide will turn lime water milky. Luckily, sulfur dioxide also turns lime water milky. So, we can write it together. Colorless gas that turns lime water milky is observed, but this was never asked in the board examination. One more non-metal you need to study, and that is sulfur. This reaction is something special. Treat sulfur with concentrated sulfuric acid. All right, now sulfuric acid releases nascent oxygen. That nascent oxygen should combine with sulfur and it must give us SO2, sulfur dioxide, which makes me write 2 sulfuric acid here. Reason is clear. I need 2 nascent oxygens. One molecule of sulfuric acid is releasing only 1 nascent oxygen. That is why I have written 2 molecules of sulfuric acid. Now, from sulfuric acid, after it releases nascent oxygen, what happens to sulfuric acid? It gets converted to water and sulfur dioxide. Here, 2 molecules of water and 2 molecules of sulfur dioxide. Remember when we started with this reaction, I told you this is a special reaction. Why is this special? Look at this. Here, sulfur is converted to sulfur dioxide by oxidation. Sulfur is oxidized to sulfur dioxide. At the same time, sulfuric acid is getting reduced to sulfur dioxide. Incidentally, this is a case where the oxidized product and the reduced product are the same. Now, you don't have to write it as SO2 plus 2SO2. When you present it in the paper, in your examination, you just can write it as S plus 2H2SO4 concentrated gives you 3SO2 plus 2H2O. 3SO2 plus 2H2O. Right? So I meant that you don't have to write it separately, which is the oxidized product, which is the reduced product. No, this explanation is just for you to understand that out of the 3SO2, one has come from sulfur by oxidation. The other 2 are from sulfuric acid by reduction. Again, observation is not a very much possible question, but let us be prepared. Color of sulfur is yellow. So, yellow colored non-metal sulfur when treated with concentrated sulfuric acid gives you colorless, suffocating odored gas, which turns lime water milky. Lime water milky. So you don't have to worry that won't carbon dioxide turn lime water milky. Yes, carbon dioxide turns lime water milky, but you have written here suffocating gas, whereas carbon dioxide has no such choking or suffocating odor. All right, so this is the reaction of concentrated sulfuric acid with non-metal sulfur. There are only two non-metals mentioned in the syllabus, and we have discussed both carbon and sulfur. There is one more reaction under oxidation itself, under sulfuric acid is an oxidizing agent itself. This is a reaction between metal and concentrated sulfuric acid. I'm continuing it under the same heading, oxidizing nature. The metal used is copper. This is the only metal that you need to study. Copper plus sulfuric acid concentrated. Copper is oxidized to copper sulfate here. Copper gets converted to copper sulfate, and along with that, you will get a molecule of sulfur dioxide and 2 molecules of water. You can quickly check whether the equation is balanced. Only difference here is I have not written copper oxide. Instead, the oxidized product here is copper sulfate. Well, this is a frequent observation type of question also. Why is this an observation question? Because very clear observations are there. Copper sulfate is a blue color solution. Now, the only two colors accepted by the icse Council for copper is you can either write pink metal copper or you can write reddish brown. No other color is accepted. All right. So pink or reddish brown metal copper when treated with concentrated sulfuric acid, gives a blue color solution. Which is copper sulfate plus water, blue color solution, along with the liberation of a colorless, choking or suffocating. Now, since earlier observation I mentioned suffocating, let me introduce another term which you can write here. The liberation of colorless gas with burning sulfur smell. So, pink or reddish brown metal copper when treated with concentrated sulfuric acid gives a blue color solution along with the liberation of a colorless gas with burning sulfur smell, which turns lime water milky. Now, actually, if you're finding it difficult to memorize such a long observation, make sure that at least pink or reddish brown metal, that color you're writing, and solution turns blue. This is sufficient for 1 mark. Yeah, but for perfection, I have explained the complete answer along with the liberation of a colorless gas with burning sulfur smell, which turns lime water milky. That is all about reactions of concentrated sulfuric acid with copper metal. So with this, we have completed all the chemical properties of concentrated sulfuric acid. It is a dehydrating agent. It's a non-volatile acid. It is an oxidizing agent. Dilute sulfuric acid is a typical acid. Now, there are definitely questions based on the property of sulfuric acid. Now, before we wind up this episode, one more small point I need to clarify here, that is, there can be a question to distinguish between dilute and concentrated sulfuric acid. So how will you identify or distinguish? Suggest a test for those kind of questions. How will you distinguish between concentrated sulfuric acid and dilute sulfuric acid? How will you distinguish between concentrated and dilute sulfuric acid? Answer is treat both with copper. Treat both solutions, that is concentrated as well as dilute sulfuric acid. Treat both solutions with copper metal, a tiny piece of copper turnings or whatever. You just write copper metal, enough. First point is dilute sulfuric acid has no reaction with copper. Why is it so? Copper is a metal which is below hydrogen in the activity series. Such metals which are below hydrogen in the electrochemical series has no reaction with copper. So only those metals which are above hydrogen will react with dilute acids. Now, so first point is clear. The one which is not reacting with copper is dilute sulfuric acid, whereas concentrated sulfuric acid with copper, on treating with copper or whatever you write, concentrated sulfuric acid with copper turns the solution blue. Turns the solution blue. This will be enough. Or you can even write with the evolution of a burning sulfur smelling gas which turns lime water milky. So here the point is dilute sulfuric acid has absolutely no reaction with copper, but concentrated sulfuric acid reacts with copper to turn the solution into blue color. So that's all from sulfuric acid. Stay tuned for more videos. We will discuss the board questions also from sulfuric acid chapter. Thank you.